This question is a standard one about electricity. You are expected to know a circuit diagram for doing this kind of experiment. So in that circuit diagram, you should have some kind of power supply, which you can draw as a cell. You should have a variable resistor, because you need to be able to get several different values. Then you will have a place for whatever it is that you are investigating. So I've just called it X. That's where you would put your thick copper wire or your filament lamp, whatever you're investigating. You need to have an ammeter in the circuit to measure the current, and you need to have a voltmeter around whatever it is that you are investigating in order to get values for voltage. You need to know that circuit diagram. That then helps you do 4 other pieces of equipment. So you need a power supply, variable resistor, ammeter and voltmeter. Okay. Give a reason why you should keep the wires at a constant temperature. He is trying to investigate the resistance of these bits of wire, these components, and resistance is affected by temperature. If resistance changes, then that will affect your results of current. Describe how you could keep them at a constant temperature. So 2 marks here. The easiest way to do that is to only turn the current on, only turn the power on for a short amount of time. The second easiest mark is let the wires cool down in between each measurement. You can, if you wanted to, try for more complicated answers, such as monitor the temperature with an infrared thermometer, or put the components in a water bath to control the temperature, but that's a bit too complicated. I would just stick with the first 2 marks. Okay, for this one, you need to know these graphs. So this graph should instantly be familiar to you. So that should be for the filament lamp, you know that. And that's because it's a curve, because its resistance is changing. So the resistance is increasing and the current is less than it should be. The second graph that you should definitely know is this one for a diode. So a diode doesn't let current flow if you try to push it one way. It does let it flow very easily after a certain point. Now for the other 2, you've just got to make a judgment. One is a short, thick copper wire, and one is a long, thin copper wire. Now you should know some factors that affect resistance. Resistance increases if the wire is longer. So this piece of wire will have a higher resistance than this piece of wire. That will have a lower resistance. Another thing that affects it is the fact that it's thick. So if a wire is thicker, that also reduces the resistance. If the wire is thicker, it is easier for the current to pass through, so the resistance is lower. So then you've got to decide for these graphs here, which one of them is going to be for a higher resistance and which one is going to be for a lower resistance. Now, if your resistance is higher, that means that your current is going to be lower. Higher resistance, lower current. And for these 2 graphs, this one has the lower current. So that links to there, and that links to there.